If you guys have any questions about this or general Unity related things, you can feel free to reach out to me via email. And you can also find me on Twitter, where I post a lot of GIFs and videos of the stuff I'm working on. I will say I get a lot of emails and a lot of messages, so if I don't respond right away, follow up with an email response to that original email to kind of guilt me into responding, and hopefully I'll get back to you. So as an overview, I'm just going to go in and start kind of defining what handheld AR is, how we're talking about it here at Unity, talk about ARKit and ARCore and kind of how they actually work, and gain a little better understanding of that. Next, I'm going to go into demos, which I'm really excited about. Just a lot of small kind of little applications that I've built, and we'll be talking about how you can start to utilize this technology in more interesting ways. Next, I'll do an overview of what ARCore is, some of its unique features, followed by ARKit and some of its unique features. And then finally, I'll just go over some kind of general tips, some things I've learned, some things you can utilize with your applications, and finally start talking about AR Foundation, which is a multi-platform solution that Unity is working on to kind of combine these SDKs. All right, so what is handheld AR? So in the augmented reality space right now, there's some head-mounted displays, there's some kind of varying technology, but this talk is focused on basically handheld AR, which is controlled through a mobile phone or a tablet device. And the way that handheld AR works, and I'm specifically talking about ARCore and ARKit, is it uses something called visual inertial odometry. And this is the combination of computer vision from your device's camera along with IMU data from things like the accelerometer and the gyroscope. And as the computer kind of recognizes the world around you, it finds little feature points and various kind of interesting things, and then it uses the sensor data from the gyroscope and the accelerometer to try to build up the world and move throughout it. And this is kind of all happening on the back end, so you don't have to worry too much about it. And some of the core features right now in these handheld AR SDKs are plane finding, so being able to find horizontal and vertical surfaces. Position tracking, and what that means is that once you've established yourself in the world, you can actually move your device around. And in Unity, and just in general, you know the orientation and the position of your device. So if you want to start kind of capturing a motion path or something like that, that's kind of a built-in feature. And last but not least is light estimation. And this is the ability to basically take in the ambient light value of what you're looking at in your device and apply it to your scene or to your augmented objects. This allows you to brighten or darken elements to really allow them to fit in the environment that you're putting them in a lot better. And as I talk today, you'll know that with augmented reality, the more you understand about the environment, the better it is you can augment objects in it. So there's going to be some unique features that I talk about, unique to ARKit specifically, that really kind of allow you to bring in elements from the environment, and when you place objects, it allows them to feel a lot more grounded and real. All right, so now let's get to the fun part. These are various demos that I've built, and they happen to be built with ARCore, but as I'll explain later, there's nothing really restricting them to this platform specifically. And the first one I want to show off is a basic example of what they're calling Hello AR. And this is what ships with the ARCore SDK. And it allows you to find planes. You can see I found one on the stage, and I found one over there on the floor. And every time you tap, you place a little Andy the Android. So this is kind of the Android mascot. And this is a very simple application that allows you to put some kind of elements here in the environment. It also is able to find vertical planes as well, and we might be able to find one on the banner back there, and then we can place Andy right there as well. So you can see him kind of hanging out there. So that's kind of the basic functionality, and now let's start to see how we can utilize this in more unique ways. So for this app, what I'm going to do is I'm going to find a ground plane here on the stage. I'm going to hit the start button and then just start walking around. Now, because augmented reality knows the position of where my device and where I am in the world, I'm able to actually drop little kind of markers behind me and track my motion path as I move around. So you can see we have kind of little tulips or flowers here that have been placed exactly where I walked. Now maybe I was wandering through the forest or something like that, and I happened to be running this app the entire time, and then when I got lost, I could kind of look behind me and maybe retrace my steps or something like that. But the functionality here is that I'm simply using the position of the camera in Unity to drop a little tulip behind me every time I move a little bit of a distance away. For the next one here, I'm going to be using basically the ability to kind of move around and the physicality that AR gives you. So for this one here, I have a little Jenga board, and when I tap, I can actually go and pull pieces out. So we can see something like this, and potentially I could go and try to kind of put it on top, maybe like that, and then I could maybe hand it off onto my friend, although the physics do get a little wonky and things kind of fall down here. But the point I'm trying to illustrate is that AR really allows you to move throughout the space. I can go and kind of move objects around, and you can see that the physics of the objects here, they've all kind of laid out on the stage here, and that's because when I spawn this little Jenga board, I just have kind of an infinite collider that goes off into space, and I'm saying that that's kind of my floor. So you can see that. So for the next one, similar to kind of moving around, you know as a developer where the user has kind of positioned themselves. So this app illustrates two things. One, I've customized the plane renderer here. So by default, as you saw in my first example, the ARCore example has kind of a grid pattern. But I believe that if you're making any sort of AR application, it's a really good idea to kind of customize it and tune it to the specific application that you're making. So for this one, we have a pattern of kind of hearts around, and when I place little up guys, you can see them right there, and when they get really close, they start to kind of dance a little bit and spawn some hearts. But the interesting thing here is that if you look at them right there, they'll do kind of little blink motions. So you can see them do a little blink right there. But if I get really close, then he'll actually do a wink. And that's because I'm just checking the distance. You can see it maybe. Oh, there we go. We can see this guy do it as well. He did a little wink. And so again, I'm just kind of checking the distance of how far the camera is away from the objects I spawned. We can kind of go and put a lot of them kind of around there, and they all get pretty happy. So again, I'm kind of customizing the plane, making it a little more unique to the application that I developed. All right, and so for this one, let's do this one. I actually need a little bit of an audience participation. So if you guys can kind of raise your hands in the air a little bit. And all right, you can go ahead and put them down. And what I'm doing here is I'm actually kind of capturing images of the audience on AR planes that are kind of just existing in the world. And so you can see we can kind of take things over here, get some of the audience there, and you get kind of a unique effect here as you kind of place objects in the world with kind of the captures that we have over here. So you get them over there, raise the hands up, and now you're kind of stuck in space there. We can get a little glimpse right down there. And so, you know, with augmented reality, you've given the user permission or to kind of access the camera. And so you can start to use this camera in interesting and unique ways besides just placing objects in the world. And I'm, placing obviously just planes here, but also taking a render from the camera itself. All right, and this last one was kind of an attempt that I made to try to blur the lines between what is real and what is augmented. And so back home, so I'm going to try to kind of find an object here. I've tried to make, thank you. This can be a little finicky on the connection here. There we go. So what I've done here, try one more time. There we go. So what I've done is I've tried to make a real basically two augmented avocados that look kind of hyper real. And so I'm using some things like reflections and shadows to really sell the idea that the object is kind of real in space. So let me hop back to my slides here. All right, so those were kind of some just demos, some examples that I've built. And they happen to be on ARCore, but there's nothing really restricting them to that platform specifically. And so now that you guys saw a little bit of those, I want to hop in and start to explain what ARCore is, what ARKit is, and some of the unique features that each of them contain. So to start, we'll start with ARCore. So ARCore is Google's solution to augmented reality in the Android ecosystem. So what they've done is, through our partnership with Google, they actually develop and maintain the SDK and the plugin for you. Inside Unity, we have an XR settings checkbox, or an XR settings label, and there's an ARCore supported checkbox that you actually need to enable in order for it to run on your applications. You'll notice it works with Unity 2017 and above, and there's a handful of sample scenes, including that original demo I showed, spawning the little Andy the androids. And so it's easy to start to kind of take and build on top of that. There's also some sample scenes for augmented images, which means that you can actually upload pictures or images that you've taken and then recognize those in your application to kind of build experiences around those as well. So for some unique features with ARCore, you'll notice that I was able to kind of find planes and place Andy on the surface here, as well as on this back banner. But they also have the ability for what they call oriented feature points. So feature points are just unique elements that you find kind of in the world, and it's what the computer vision is using to kind of track and orient itself. And with oriented feature points, it's actually the ability to get kind of a normal or a directional vector off of a feature point that you found. So you can see here on my laptop, I'm able to place Andy kind of at a unique angle specific to that laptop. I haven't found a horizontal or vertical plane on it. Instead, I'm just placing Andy on the feature point, and the feature point knows that it is kind of attached to my laptop that's slanted a little bit. So that's kind of a unique way if you're trying to place objects kind of relative to maybe a circular object or something like that, you can use this feature here. The other kind of unique features that ARCore supplies is something called cloud anchors. So this is basically the ability to create kind of multi-platform or multiplayer experiences in AR. And what they do is, as you kind of find and scan the environment, when you place an anchor, which is used to kind of place those Andys around, it actually uses Google's services to kind of push that anchor information up into the cloud, and then another device could kind of resolve that. And when they've found a similar plane or orientation, it'll recognize that that is the position of the anchor. And the cool thing is that it actually does position and rotation. So you guys will be able to see the exact same kind of augmented element between both devices or multiple devices. And then last but not least, there is an ability for instant preview. This allows you to have the Unity editor open. When you hit the play button with an Android phone connected, it'll actually kind of push a APK to it and then send AR data back to the Unity editor. So this helps a lot with kind of iterating and debugging a bit. So for building on top of or kind of getting started with Hello AR, this is again that little sample app that I showed. The nice thing is that they have a script here called Hello AR Controller, and it just has this reference to the Andy prefab. If you wanted to create a very simple augmented reality experience where you had your own custom model that you just kind of wanted to place in the world, it's really easy to download this SDK, swap out Andy for that custom model, and then start kind of building on top of that. And one thing to keep note is that the way ARCore works is that for the session, which is kind of when you've given access to the camera and when the AR technology starts to work, is that it's all configured through a scriptable object kind of shown here. So depending on what features you're trying to access or what you really care about, make sure that you're kind of checking the checkboxes or configuring the drop-downs here. I've spent more time than I'd like to admit kind of debugging things when they weren't working, and it just kind of wasn't configured in the session. And last but not least, so I kind of briefly mentioned augmented images. So both ARCore and ARKit support this functionality, but it's implemented a little bit differently in each platform. So for ARCore, they actually have the ability to go and kind of multi-select any image that's in your project, and then you can go through this create menu to go ahead and create what they call an augmented image database. And the cool thing here is that you can see on the far left there's that quality bar, and it'll actually run the computer vision algorithms on it in the editor and give you back a score of how well the computer can kind of recognize those images. So they suggest putting images that have a score of 85 or above, and those are going to be the easiest and quickest to recognize and kind of lock to that specifically. And the cool thing is that with ARCore, they support up to 1,000 images per database, and they also have some technology in place, while the examples aren't fully built out, to actually kind of sync in and feed these image databases at runtime. So you don't necessarily have to compile them in your application off the bat, and potentially you could kind of feed those up to a server, run them through this algorithm here to create this database, and then deliver that back to your device. All right, so now let's talk about ARKit. So similar to ARCore, ARKit is Apple's augmented reality solution. So this means that it is available for iOS devices like iPhones and iPads. And similar but different is that the ARKit plugin is actually maintained and developed by us at Unity. So Jimmy is an engineer that sits in San Francisco, and he works a lot on the actual implementation here. Now, obviously, he works closely with Apple in order to make sure that things are implemented and running correctly, but it's a little bit different of an experience because of kind of the samples and things that Jimmy has built up compared to the more lightweight example with ARCore. So for ARKit, you can see that the sample scenes kind of include everything. I think we're up to over 40 different sample scenes for all the unique features. And so if you wanted to kind of get started and start taking advantage of some of the unique features or just some kind of basic UI and UX, there's a lot of stuff included there. And you can see we also have some kind of helper things that while they're included in the ARKit plugin, there's nothing really restricting them to the iOS platform. So these are things like shadows and occlusion. And these are special shaders that are kind of optimized for mobile, running specifically, or kind of included specifically in the package. And then lastly, with ARKit, Apple has included the face tracking, which is available on the iPhone X. So this is kind of encompassed under the umbrella of ARKit, and all the examples and functionality is included in this plugin as well. And the nice thing too, because of our partnership, similar with Google, is that when new features get announced, like at WWDC for ARKit, the 2.0 features were actually available and the branch was pushed for you to get access to the day it was announced. So we're kind of really staying on top of it and really want to make sure that we're giving you the tools as well as the sample scenes to start building on top of these new features. All right, so talking about building on top of it, similar to kind of ARCore, we also have a kind of session config, but this is actually just a script itself. So again, you can see we have things like detection images. Those are what they refer to for the augmented images, as well as different things like being able to kind of autofocus. So this is just a functionality of mobile cameras, being able to kind of focus at different levels and different drop downs from there. So some of the unique features with ARKit is the ability to create environmental probes, which I'll show here in a moment, world maps, which are basically the ability to kind of scan the environment and then save point cloud data as kind of an asset or a file on disk. And what this allows you to do with world maps is that I can go and scan an environment, then I can share that world map either via kind of airdrop or any sort of associated thing with that. And then another device can go, and once they've found the same world map, we can kind of relocalize together. And so this example you're seeing here is kind of a multiplayer experience. That's Jimmy there. He does a lot of the work for the ARKit plugin, and that's me kind of dropping little orbs. And what we've done is we've found the same world map. We've localized ourselves to the same kind of common environment, and then we're just syncing input back and forth to kind of place orbs in the world. So I mentioned that ARCore supports augmented images. ARKit supports augmented images recognition and tracking. So if you wanted to find the image and then the image is kind of moving around, or you wanted to kind of play with it where it gets close to two images, you can do this in ARKit currently. We also have object scanning and recognition. So similar how I mentioned with the world map, you can actually scan specific objects in the world and kind of keep those again as a file on disk and share those or build those directly into your application. So I could go and kind of scan this water bottle, and this water bottle is, maybe a little bit shorter than normal water bottles, but if I scan this and then maybe put like a particle effect or something like that on top of it, anytime anyone else used my application and it kind of recognized this same water bottle, it would start to pop up that augmentation on top of it as well. And you can go and scan certain objects, or you can do a larger scan at kind of the world scale there. And of course, face tracking kind of included, available for the iPhone X. In ARKit 2.0, they added the ability to recognize a tongue, so that's kind of a unique feature there. And the other thing I want to talk about is environment probes. So for me, this is something that's super exciting. It, again, goes with this idea of the more you understand about the world, the better you can kind of augment objects within it. And what we're showing off here is this is a basically shiny structure that I created. And when you place the environment probe in the world, it uses textures and information that it's found about the world to create a cube map. And then this cube map just gets assigned to a reflection probe in Unity. And then any object you have near it just takes those reflections. So you can see here, this is kind of a park bench near my apartment. And what I've done is I've kind of did a little bit of pre-scanning, and it was able to capture that texture of the bench. And then when I spawn this object, it's able to use that with the reflection probe to kind of reflect the environment that it's within. And with the environmental probes, there's the ability to do it manually, which says I want an environmental probe to be built here specifically, or you can do it automatically. So as you kind of move throughout the world, it will find unique places as well as kind of increase the size of the environmental probes as it gets more information. One thing to note here is that it does use feature points and plane finding to build up this cube map. So I made a little video one time where I was kind of trying to build up the cube map. I was scanning around, I looked at the sky and things like that. And an Apple engineer actually reached out to me and said, hey, when you're looking at the sky, there's no feature points. There's no planes that you're going to find. So it's not able to actually kind of build up an environmental probe based on that. And again, kind of similar along those lines, is I found that this works a lot better inside than it does outside. So just something to keep in mind there. But you can see that does produce some pretty cool results. All right, and so face tracking, this is available only with the iPhone X, but it does offer some pretty cool features. So it allows the ability for a face anchor, which is basically a transform point that is stuck to your face as you move around. It also allows the ability to mesh the geometry of your face. So this is using that depth sensor included and is able to create a kind of a facial mesh around your face. And then lastly, it includes 50 blend shapes, which are basically kind of float values determined by different kind of attributes or muscles on your face. So it has things like jaw open, right smile, and things like that. So as you move your face around, you can link into those blend shapes to kind of apply logic or do different things with those. You can also use them to drive kind of animated characters or facial rigs through animation. And so you can see here's some kind of examples of what we have going on. And up at the top there, that's Jimmy with the face anchor. And you'll notice that it's kind of embedded in his head a little bit. So if you're trying to kind of maybe attach a mustache to somebody or something like that, keep that in mind that you're going to have to offset it a little bit. The facial mesh is kind of Jimmy looking a little surprised there on the bottom. And on the left here, I actually am combining all three of these features. So that's obviously me kind of opening my mouth, shooting out some particles. And what I'm doing is I'm using the face anchor to kind of lock the particle system to my face as I move around. I'm using the mesh geometry to actually create an occlusion mask. And you'll notice around my kind of lips or around my face when it's actually coming out, it's occluded a little bit. So it looks like it's really coming from inside my mouth rather than just kind of rendering on top of it. And then lastly, I'm linking into the blend shape value of how open my mouth is. And this allows to kind of turn on and off the particle system there. All right, so I've talked a little bit about, what is ARCore, what is ARKit, what sort of features and functionality they have, and showed you guys a little bit of my demos. And now I just want to talk about some kind of tips and things that I've learned while building a lot of these applications. All right, so the first tip is to use feature points. So I've talked about feature points, and these are kind of unique elements that the computer vision sees and is able to kind of position objects on. And the way planes get built up is it actually finds basically 3 or 4 feature points and then determines that that's a plane. Now, you can use feature points, similar to that kind of oriented feature points, to actually place objects and kind of do a raycast against in the world. So if I were to create an application where I wanted to measure the height of this podium, it would be a bit tedious or potentially kind of long to kind of find a plane up here, then find a plane down here, and then kind of go and measure it. And instead, you can actually just use feature points. So I'm able to find a feature point right here and start kind of measuring right away, and then go down and find one there. So if you don't need to kind of put objects on the floor, you don't need to ground them to planes, consider using feature points, which is going to happen much quicker instead. The next tip is to kind of check the tracking state. So all of these SDKs kind of rely on the user kind of moving around a little bit, maybe scanning their environment. And as someone who uses this a lot, I'm very kind of apt to do that. Every time I open my apps, I'm kind of doing a light scan. But if you give it to, say, maybe a young child, they might be kind of moving it around a lot. And what you can do with these SDKs is you can actually link into the specific tracking state. So if tracking is lost, you might want to restart your experience, or you can just tell the user what's going on. So for ARKit specifically, it actually has the ability to return if there's excessive motion. So if the device is kind of being moved too quickly and the camera can't really tell where it's at, as well as things like insufficient features. So I was able to kind of find feature points on this banner here, but it would be pretty difficult to find and place any objects on, say, this white wall over here. Because as I look at it, there's no real shadows, it's kind of just plain and things like that. And so you could tell the user that not enough feature points have kind of been found there. And lastly, always check performance. So, at the end of the day, you're still building for mobile devices. These are still phones and things like that. While they are kind of leaning more towards the high end, you need to make sure that you're hitting these performance values and make sure you're still developing a mobile app. So for ARKit right now, it's able to render at 60 frames a second, and ARCore is limited to 30. Now, something to keep in mind is that if you're getting bad performance, it's going to look like the camera is rendering fine, things are looking fine, but you're going to get some kind of noticeable differences in tracking and things like that. So you might notice kind of objects getting placed there, and then maybe drifting off into the distance. And I've had a couple times where I was like testing and building an app one day, everything was looking fine, and then I come back the next day and I've added a little bit more, added more functionality, and the tracking seemed bad. And I was like, man, ARCore is just not working very well today. But really is that the performance wasn't good enough, and the difference between the camera and the virtual objects there are what you'll notice. All right, so the next one is just kind of guide your user to what you need. For these AR applications, it's always good to kind of understand and maybe do a little pre-scanning of your environment. So creating some kind of UI or some incentives for your user to look around before you're able to place objects on the ground is always a good idea. The next thing is to use real-world size. So in Unity, similar to virtual reality, the size and scale at which you create things are relative to the real world. So if you create a 1 meter cube in Unity, it's going to be 1 meter high kind of in the environment that you spawn it in. So I've ran into some issues where I'm just kind of creating content, looks good in the scene, build it out, I place it in the world, and I have no idea where it's at. And it turns out I'm kind of just inside the geometry, clipping through it. And so you kind of have to walk 100 meters away, then you look at it and kind of see it from there. So just kind of keep that in mind when you're authoring your content and when you're putting it in augmented reality. And next, just think about object interaction. So oftentimes you want to find kind of a ground plane and put an object on it. And while you may want to adjust and move that object around, you almost never want to adjust the Y height of the object. So once you've kind of placed it in the world, you might want to move it around in the X and Z direction. but you never really want to move it down because that's just going to kind of be below the ground and potentially getting some kind of weird rendering issue or kind of disconnect between what the user is seeing and what's in the world. All right, and so this one for me is huge. You know, the world that we live in has shadows everywhere. Has shadows everywhere. Everything casts shadows unless you're in some sort of photography booth. And to me, it's really important and a really good idea to include shadows in your application. And so we can see in a little video here, this was something that I created just to kind of show off some size and scale. And you can see some of those issues there. And you can actually see that all objects are casting shadows based on the shape. And so this is a shader that's included with ARKit, and it allows you to, it allows transparent geometry to accept shadows being cast on them. And so what I've done is just created a really large shadow at the bottom of my kind of application here. And let's see if we can reset it. And it just kind of is basically a transparent plane that has this special shadow shader that's included in ARKit. And then I have a real-time directional light that's going and kind of casting these shadows. And something that's kind of unique to this video here is you'll notice that, and this is me kind of cheating a little bit, is I've actually turned the directional light and the shadows to be cast as the same direction that the shadows are being cast in real life. And you can see this woman moving right there, and her kind of shadow is a same direction of what we're seeing in reality. And so that's just a good way to really ground your objects and start to make them a little more believable within the world they're in. And while these accurate shadows can be a little bit expensive, depending on what you're doing, you can also get away with some blob shadows. And so what I mean by this is, I'm just gonna pull up this little example here, is this is just an application here that I'm using the environmental probes to kind of place these objects in the world. And you'll notice that this kind of plus sign there has kind of a shadow underneath it. And all that is just a texture on a plane that I've kind of adjusted the transparency on it as well. But you can see that it really kind of sells the effect and really grounds the object in reality much more than if it wasn't there. All right, and last but not least, your device and your position is tracked. So we saw these little guys earlier, and just using this as a tool to kind of get people more immersed or more into your experience is a really good way to kind of enhance the experience, use it in interesting ways, and kind of track it as you move throughout the world. All right, so this next part is basically about AR Foundation. So I've talked about ARCore, some of the unique features there, talked about ARKit, some of the unique features there. And what we're doing at Unity is we're combining those into a single project that is able to maintain the same code base, and depending on what platform you're outputting it to, is able to kind of use ARCore or ARKit behind the scenes. And we're calling this AR Foundation. And the big thing I want to emphasize here is that AR Foundation covers the core functionality. It's not going to be able to use the environmental probes and things like that yet, but that's something that we're building up. So what we're defining as the core functionality here is things like plane detection, light estimation, hit testing, things like scaling and anchors. And what it allows you to do is it's all delivered via the package manager. And if you're not familiar with the package manager, I'm going to show a small kind of little demo of how it works here. So this is an application I was building a little bit earlier, and the package manager is available only in 2018. So you're going to have to use kind of the newest iteration of Unity here. And with this, you can go to the window, package manager, and this is going to be a list of all the packages that are in your project, or you can go to the all, and you can find all the packages that we're working on here at Unity. So if you wanted to include things like 2D animation or 2D IK, you could just go and click this install button in the upper right. Now, you'll notice down here, I've actually already installed the ARKit XR plugin, the ARCore XR plugin, and then the AR Foundation plugin. And this is the glue that kind of maintains those functionality up into this kind of abstracted layer, so that when you're building on it with Unity, you're only worried about kind of this single functionality. And so just as an example to show you guys a little bit how this works is I've already kind of included these. You can see them in my project. You can see them a little bit here, and it goes through and kind of tells some of the functionality. So I'm going to go and create kind of a new scene. And once I've imported those into my project, I now have a new drop down in the create menu that allows me to create these AR kind of components. So with XR, I'm going to go XR AR session origin, XR AR session, and then I'm going to go ahead and delete the directional light in the main camera, because this is actually already kind of combined within these kind of prefabs that I've made. And you'll notice one thing, that with packages, we actually hide a lot of the functionality. So the ARKit and ARCore plugin, as well as AR Foundation, are included in your project, but you'll notice that they're not showing up over here in your project hierarchy, and that's because it's just kind of linked into it behind the scenes. So once I've done this, I can go and kind of add certain scripts and samples that are included on here. So we have things like a plane manager, which is looking specifically for a plane prefab. And so again, I could go and create that in my scene. So we have a default plane here, kind of drag that over like that, and then just assign it in here. Now, the nice thing that we've done here at Unity is that while we can't ship this full kind of scene setup and things like that within the package itself, we've created a separate repository that actually has all of this setup taken care of for you. So if you want to go and download that, it's available on GitHub, and you can see kind of how to set this up. It's a little example scene that allows you to go around and kind of place objects throughout. And so I'm kind of wrapping up here. This is kind of the final thing I wanted to show, but I did want to show you guys that how easy it is to kind of maintain a single code base and deploy across multiple devices. So we can see if this works here. So what I have here is an application. Let me clear it first and relaunch it. So what I have here is an application that I built with AR Foundation. It allows you to go find some planes like this and place little chairs around. And so pretty basic, nothing too complicated. But what I can do here is I've actually built this same application out to my Android device here. So that one was using ARKit, and this one is going to be using ARCore. If it appears here, like that. And again, this is kind of the same code base. Let's see if this connection. Let's try this one more time. It's the same code base, the same functionality. I've just built one out to Android and one out to iOS, and now we're able to go and kind of place the chair up here, but you guys can't see it. But it's basically this kind of cross-platform concept, and it really eases the use. It's really lightweight. One thing I'll note is that this is kind of super hot off the press. We just released it. Oh, you guys might have seen that. I was there for a second. We just released it very recently. There was a blog post about it. We're contributing and building up a lot of samples still. So kind of keep that in mind, that we're going to be supplying a little bit more details on how it works and things like that. So kind of look forward to those. And if you guys have any questions, of course, feel free to reach out to me. And thanks a lot for coming. So.